Good evening. My name is Isabella Bufacchi. I am a journalist. I am the Germany correspondent of Il Sole 24 Ore, and I have the pleasure to be here tonight, and thank you for inviting me to be moderator of this event that will make us fly in the space. And it's always exciting to talk about space. The Italian Embassy in Berlin celebrates with this event the third National Space Day that commemorates Italy's launch as the first nation besides USA and USSR of an orbital satellite in 1964. So this event is devoted to astronautics, grassroots satellite launch, and military applications. But it's not to me to say it. Please give the floor to the Ambassador Armando Varricchio for the introductory remarks. Thank you.
Grazie Isabella. Thank you very much. Good evening, everybody. Welcome to the embassy. It's such a pleasure to be part of the celebrations of this week when Italy, an old nation, but always with a great appetite for the future, celebrates space. Space, which is the future of humanity, space that is a topic that now figures very much on top of the agenda whenever political leaders meet. And that was the case just last week when our Prime Minister was here visiting with the Chancellor Scholz, with a very large part of the Italian government, the two governments meeting in their consultations, and space was considered because Italy and Germany have so much in common. They do understand and do agree that it is very important that as nations, as members of the EU, as great democracies want to talk about the opportunities that space is offering to us. Isabella reminded us of the very beginning. We are very proud that Italy, just after the two giants of those days, the USA and then USSR, made this great jump into the future. But since then, we have reached many achievements, and we do consider ourselves a very important player in this field. The Italian government has so far celebrated and established the National Space Day as an opportunity to make the general audience more familiar with the world of space and to highlight the contributions from Italian research and institutions, both public administrations and industries. And this is why we have invited here important speakers tonight. I would like to acknowledge them. We have General Cipelletti. Thank you very much, General, for attending our event. And if you allow me a special appreciation to General Vittori, an old friend. We worked together in the United States at a time when General Vittori was space attaché as one of the great regional pride of Italy as an established astronauts. And then we are very pleased to have here Colonel Frass, representing his government, the German military, to these discussions. When we talk about space, of course, we do consider the economic opportunity provided us by the space economy, at the same time public welfare, sustainable development, environmental protection, while not neglecting national security and, of course, what has always been a strong strive to research, which is a very healthy competition about great nations, putting at the disposal of this higher cause their technology, their research, their innovation. Because we do consider that the benefits that we all might grasp from the space sector will be so important for us all. Indeed, these are exciting times for the space sector. The individual national space agencies, as well as ESA, the European Space Agency, and both also private actors from different countries that never had direct access to space are embracing a new strategic vision that departs from the traditional concept of access to space. And this is why, as I was mentioning before, the new space economy, we do think that will offer novel opportunities to launchers that allow not only to reach the International Space Station, but, as it is expected, also to reach again the Moon, with the intention of establishing a permanent presence in order to use the lunar soil to extract useful resources for the Earth. Italy is absolutely and extremely active in this respect as the second largest contributor to the European Space Agency. At the European meeting of ESA, the Italian minister competent for space, Adolfo Urso, signed with his colleagues from Germany and France a joint declaration to start again to relaunch the EU space sector. The aim of such an understanding is to boost the availability of EU launchers and spaceports. I was mentioning earlier on the meeting that our two governments had here in Berlin. They discussed research, development issues, as well as upstream activities, downstream services and applications, space legislation and regulation. Italian and German, both civil and military actors, can deepen the cooperation related to space. Especially the industrial cooperation between Germany and Italy, the two largest manufacturing nations in Europe, also in the space sector can usher a new phase for economic integration, in a similar way as we experience in so many other important sectors. This is why I'm very pleased to host tonight such an event, which will offer us the opportunity to get an overview of space activities at different heights, as we might say, and with different goals and different reach. So it is a true pleasure also to highlight the efforts of young developers of new technologies, a generation which will lead a great transformation of the new space economy. So we will start at relatively low height, let's say with contributions from high school and university teams, both from Italy and Germany, because German space is certainly our future, but first and foremost is your future as young people. So I think that you will have the opportunity to explain us your passion, your dedication, and to guide us through a journey from your labs to the launch pad and to successes in international competition. Then we'll move on to a panel discussion focusing on the Earth orbit and beyond, with a focus on defense applications and importance to ensure an intense cooperation between the civilian and military sector. So, dear guests, we are entering, as we all know, a new era of exciting discoveries, as we realize every time we watch the images we receive from the new generation of telescopes. And thanks to the new technology, your technology, sky is not any longer the limit. So we want to go beyond, to explore new opportunities. Our life has been marked by exploration, and the opportunities offered in space are absolutely amazing. We live in challenging times, but we do think that what we achieve in space might eventually make life on our dear but fragile planet Earth better, healthier, and more peaceful. So let's start the journey tonight. Thank you very much.
Thank you, Ambassador Varricchio. Indeed, it is the young who have to speak also to bring us to the future. And I now introduce the first presentation of the projects. I point to that table because you can see there, I've brought, there are 4 projects. 3 are here, and one I heard some rumors that maybe it was not easy to bring it on an airplane over. So, but then it will be explained to us. So the first presentation is by Alina Bachmann, Kaiserin Friedrich Gymnasium di Bad Homburg, and please. The title is CANSAT, More Than a Competition. Please, Alina, the floor is yours.
Thank you. Good evening, everyone. Allow me to take you on a captivating journey. A journey that begins with a simple question: why not? Many children dream about being part of the aerospace industry one day. While it may seem like a giant leap, our story proves that it only takes that first initial small step. Or, as my team would say, building a mini satellite with a scientific mission and carrying out your own space project, why not? This opportunity was given to us by CANSAT. CANSAT is an ESA competition for students between 14 and 19 years. Its aim is to simulate a size-down space project. There are 2 levels of the competition, the national and the European. For both, 2 reports have to be written. The evaluation is based on 4 categories. We have the technology, science, professionalism, and PR, public relations. But since everything revolves around the mysterious CANSAT, what is a CANSAT anyway? This, for example, is our CANSAT, or you can see it divided here in the slides. A CANSAT is just simply a miniature satellite the size of a beverage can, which is then launched by a given rocket of the DLR to an altitude of 700 meters. During the fall, it fulfills 2 missions. The first mission, or the primary mission, is to measure the air pressure and the temperature. The secondary mission is self-selected by each team. In every national competition, we have 10 teams that are selected beforehand. Let's come to our secondary mission. Our secondary mission was inspired by our German ESA astronaut Alexander Gerst, who posted this via Twitter. He drew attention to the severe drought associated with forest fires. Accordingly, we have set ourselves the task of detecting the risk of forest fires in order to counteract a potential fire at an early stage. And as a small add-on, we also installed a reaction wheel to keep the image quality constant. Our objective marked the start of an important journey for us. We networked with a number of people, from politics to industry. We gave presentations to convince the sponsors of our ideas, with success. At the same time, we designed, built, and programmed the CANSAT. And we often went on trips, either to work out the scientific principles ourselves or to learn from lecturers. Once we went to a lake, You can see it there. We built everything up then, and yeah, we were just ready to go. But then, unfortunately, the rain came. And just like our great role models, we had to postpone the test for a few days, and that was not just once. During our turbulent journey, we were even accompanied by the German television program Die Sendung mit der Maus, also known as Die Maus. This allowed us to reach around 2 million children and encouraged their interest in adventure and space travel. Then, after 6 months of preparation, our time had come. After a short presentation, our CANSAT was subjected to various pre-launch checks. The excitement grew. We thought about thousands of questions. Have we done everything correctly? Does it meet all the required dimensions? Does it fall as it should? Does it transmit the data? And then it was clear, we were allowed to launch. You saw our launch in the video before, but it wasn't over after the launch. Then the work started. We spent a whole night sifting through the data, and we put all our energy into getting the most out of it. The next day, we presented our results to the jury. In the end, we won the German competition and were named the most professional team in Europe. We held the awards in our hands. We achieved our goal. But did we? Fortunately, we realized early on that CANSAT is more than a competition, that the journey itself is our goal. We met people all over the world who are interested in giving their dreams the voice they need to achieve great things, even at a young age. The spirits of science weld us all together. Once again, we were working together and not against each other. We were all committed to our goal, but we know that no one would cross this finish line alone. Apart from external support, we knew the most important thing is teamwork. Who would stand up for the team? Who would motivate them after a loss? And what path would they take to become this great team? Well, now you know our path. It was inspiring, energizing, and breathtaking. But we mustn't forget that it all started with one small question: why not?
Thank you. Thank you, Alina. All this came out from a small can, because that was the first word you mentioned. And yes, I think teamwork, but I see also a lot of knowledge, a lot of study. And so please keep it up. Maybe one day we'll see you in a satellite station. Thank you, Alina.
Thanks for the invitation. We feel honored.
Now I introduce the second project by Lieutenant Alessandro Di Schiena, Italian Air Force Academy. And here the title is The BreakSat Club Journey to Space. Please, Alessandro, the floor is yours.
Good evening, everybody. Tonight I'm presenting the journey of CANSAT team, the BreakSat Club, which participated in the International CANSAT competition on its 2023 edition. Here we have a quick overview of the agenda of tonight's presentation. And here is the complete BreakSat Club team, with all the people that contributed to the effort of this project, and in particular our university advisor and all the team members that specialized in different technical areas. Moving onwards, the competition is an international competition very similar to the European version of the CANSAT, with the only exception that it's extended to every nation in the world. And the selection of the different teams that were going to launch their CANSATs started with the preliminary design review, which took place in February. And the selection was supposed to select the 28 teams outside of the US, which presented the most innovative designs. Actually, we had to present 2 alternative designs and then choose between them the final one, which was supposed to be developed in the 2 months separating the preliminary design review and the critical design review, which took place in April, where we had to present the final configuration and the final project of our selected design. Moving onwards, we had to perform a number of environmental tests in order to assess the resistance of our system to the to severe drops, and then also to severe vibrations which were involved during the flight of the rocket, and then finally some ground control station tests. In the end, we reached the final phase, the launch, which took place in the Virginia Tech campus in the USA during the month of June. And also at the campus, we had to perform a post-flight review, assessing the flight and all the issues we had, the performances of our system, and the final results of the competition. Here are some pictures. I wanted to focus on the first 2 in the upper part. Here you can see our team on the left side describing the system to our Mexican colleagues. And on the right side, you can see an overview of the gigantic tent. Underneath, there were all the teams preparing their CANSATs in the campus in order to give them to the organizers of the competition and load them inside the rockets ready for the launch. On the bottom left side, you can see our antenna operator, and behind the umbrella there was the ground control station operator. And on the right part, our team working on some late issues. The concept of operation of our system was quite basic. The system was loaded inside the rocket that ascended up to 720 meters. Then there was a first separation, and as you can see here, the CANSAT was expelled from the rocket with its own parachute. Then there was a free fall phase up until the 500 meters threshold, where there was a separation between the external container and the inner probe, which had to open those 4 fins that you see here in the picture, which were supposed to slow the CANSAT down into a controlled descent of approximately 20 meters per second of speed. Then we reached the 200 meters and there was the deployment of the final parachute, and then a smooth landing. That was what we expected the CANSAT to do, actually. It didn't go quite as planned. Here you can see the CANSAT in its stowed configuration on the left inside the container, and here the deployed configuration with the landing system, those 4 legs. And here you can have a look at the inside of the frame of the system. And here a solution that we found quite innovative and quite efficient, which was a plug-in module with all the electronics, the batteries, which was inserted just before the launch in order to allow us to modify everything with, without touching the frame, which is quite complicated, as you can see. We implemented a lot of different technical solutions. First of all, we used a lot of carbon fiber, especially the carbon fiber, the lamination of carbon fiber fins. Here you can see the 3 different passages, and these pictures were taken inside the Dallara SPA, which is an Italian company that specializes in producing carbon fiber frames for racing cars in Formula 1, Formula 2, and so on. And another important technological solution we implemented was the computational fluid dynamics analysis, which allowed us to estimate the speed of the air around our system during the free fall, also the forces and the final descent speed of our system. On the bottom side, you can see the release mechanism. There was a wire which was supposed to cut the retention cables that activated all the mechanisms. This is a quick video of the phase where our team leader is loading the rocket on the launch pad. The CANSAT is inside the rocket. This was quite a delicate phase because we had to perform, meanwhile our team leader was loading the rocket, we had to perform all the calibration phases and the operations, which were quite sensitive, and also because of the temperature. It was summer and there were about 40 degrees Celsius, so the electronics were a bit stressed. Moving onwards, we have the second video, which is the launch phase. As you can see, the system had to withstand a significant acceleration, and also from this point onwards, we completely lost sight of our system because of the bright sunlight. So we were able to track it just thanks to the GPS system, and we found it, as you can see on the upper right side, crashed into one of the nearby fields. This purple is the container. What happened is that we accidentally broke during the assembling phase the mechanism that was supposed to release the probe from the container, and so the container fell at maximum speed directly to the ground. The only positive aspect was that when we retrieved the container and the CANSAT, we opened the container, and inside the probe was working and completely operative. We also had the signals from the ground control station, so the mission was only partially achieved. However, thanks to the other contributions of the other phases of the competition, we reached the 9th place overall and the 2nd place in Europe, which was quite a good result because we were participating as an Air Force Academy just since the 2022 in this competition. So the know-how is improving, and we are passing our knowledge to our youngest colleagues. We learned a lot about this competition, especially we implemented an analysis which is called the HFAX method, which is used in the Air Force in order to analyze the causes and the possible solutions to the different aerial accidents that occur in our operations. We found 5 important factors that involved that caused our partial failure. First of all, the human factor. We were very stressed because we had to give the CANSAT fully operational to the organizers in order to start the launch, and we were battling with some issues with some links that were not working properly. Due to these human factors, we were led to a decision error, continuing the assembling phase without stopping a second and thinking through the different phases. We went straight on, and this caused a perceptual error. We used a retention cable, which was supposed to separate the system, which was too short. And the crew resource management. Everyone in the team, we were about 11 people. We were all around the system, trying to give our best contribution to the cause, and we ended up compromising our duties, our roles, and this was caused an even worse and more stressful environment. And in the end, we didn't have a proper plan in case of a major failure like that. These were the 5 most important problems we had, but here we have the different skills that we took home from the USA and from the whole competition. First of all, technical skills. We learned a lot, as you have seen, about engineering know-how, and we were also a mixed team composed by engineers, pilots, and other officers, so it was quite challenging. We learned a lot about prototyping. Most of our system was produced, first of all, with the 3D printer, and then we ended up with the testing. The organizational skills, we learned a lot about time management and long-term planning, and also, due to the failure, the crew resource management. Finally, the human resources. We learned a lot about the team working, the importance of leadership, and in the end, the fact that the human factor is one of the most important in this kind of experience. This is the end of my presentation. I just wanted to thank the Air Force Academy for giving us both the intellectual and material means to perform and to participate in this competition together with the University of Naples, and also our sponsor, the National Council of Research, the Aerospatial District of the region Campania, and also Dallara Automobili. Thank you for listening.
Thank you, Alessandro. Very interesting. You stressed the human error and the human factor, but we also moved from the moon to Mars with the human error. So the error then is corrected, and I think there are plans now to take material from Mars and bring it back here. So we're moving on, and the errors are overtaken. So thank you.
They are the first step towards success. Error is the first step toward success. So
Good.
that was a start for us.
Indeed. Thank you.
Thank you very much.
So now we move onto the projects of CubeSat. And the first is presented by Dr. Federico Basana of the University of Padova. And the title is AlbaSat, the first CubeSat from University of Padova. Please, Federico, the floor is yours.
Thank you very much. Thank you, everybody. Good evening. I'm Federico Basana. I'm a PhD student from the University of Padova, and today I will present you the project that the university is currently developing in the field of CubeSats. We started the project from a student initiative, so from the bottom of the university, in 2019, with one objective: to build, develop, launch into orbit the first CubeSat in the history of Padova. In July 2020, we concluded the mission definition review, and then in March 2022, we finalized the feasibility study. In the middle, there was Corona time, so long time for that. In January 2023, it happened maybe what is our major goal, which is being selected in the Flyer Satellite Design Booster Initiative from the university, from the ESA, the European Space Agency, that permits us to be followed by ESA experts during the project. So, before starting talking about our mission, what is a CubeSat? A CubeSat is a very small satellite with dimension of a unit, which is the bricks that build the satellite, of 10 per 10 per 10 centimeters of the edge. The weight of the unit is 1 kg.33 kg. So the funny part is that we can build together more unit to create bigger and bigger satellites, so create 2U, 3U, and so on. We currently developing a 2U, so 2 units put together. Inside the CubeSat, we make an Italian joke. It's like a lasagna. It's full of PCB board put one over the other in order to perform different functions. Here it's it's our actually design, but usually it's quite standardized for every platform that it's launched into orbit. What are our scientific objectives? So, the first one is to collect in situ measurement of the space sub-millimeters debris environment. Usually one image in space has an empty, has something that has nothing inside, but it's full of small debris caused by the human activity that travels very fast. We talk about relative velocity of 14 kilometers per second, and this can cause the major failure of a mission. So the only way to measure them is to go into space and measure them when they impact the satellite. The second objective is to measure the microvibration on board the CubeSat, which is very important for missions that require highly stable pointing accuracy. The third objective is to perform precise orbit determination through laser ranging. So we shine a laser from Earth, and through some physics, we get the very precise position of the satellite. The last objective, but not the least, of course, is in collaboration with the Department of Information Engineering, with a group called the Quantum Future that works on quantum communication. They asked to add a payload to us, and so we added their payload in order to validate the quantum ground station on Earth. What our mission shall do? It's obviously divided in several phases. The first one is to reach the orbit, which is a 500 kilometers SSO orbit. Then we will do, as usual, the commissioning, so try to verify that everything works properly and everything responds to the commands. Then we will enter the routine, so we'll perform the science of the mission. We will turn on, turn off the payload, and so on. And the last part, which usually is not considered, is the disposal. This is fundamental in a mission, since the satellite can be a threat to other satellites and also to humanity. If some satellite re-entered the orbit and doesn't burn completely, that's a problem, because someone can be hit by the satellite, so we doesn't want that. We are currently developing 4 payloads. The first one is the impact sensor that you can represent here. It consists of several stripes, conductive stripes put together, and when they are hit by debris, they can find that something happened and that they count the impact. So this is how it works. The other payload is a microvibration payload. Here you can see the development model, which is super full of jumpers and board and things, but it's very simple. It's just a microcontroller put together with an accelerometer, and the final version will be very compact. The other 2 payloads are mirrors for what concerns the laser ranging activity, and the quantum payload is quite more complex, but I'll try to keep it simple. We are going to shine a quantum signal from ground. The quantum signal will be reflected on orbit, but while reflected, we will modulate the signal through some mirror movement or partial covering of the mirror. And so we will obtain a modulated quantum signal that will mock up a quantum K in space. It's very complex, but this is the easiest way to understand it. And this is because we can validate the quantum ground station that currently are developed on Earth. Now comes the fun part. Students develop and create the payloads. So I bring here what we did for the impact sensor, and this is the reason why it isn't here today. We bring it to the shooting range of Padova, and to understand if it works, we shoot at it twice. So here it's the video of the first shoot, I think. This is not the student. This is the gold medal from Italy championship. And the second test that we did, it's the vibration test. It's something similar to that. So we shake it a lot just to verify that it will survive the launch and the load that it will experience during the launch. So as a result, we found these 2 holes, but they are not holes, and this is the good part. And we managed to understand that without watching the experiment, the sensor just told us, something hit me, Okay, so it works, and this in space is TRL4 for the most technical part. So I'm here just to present this project. I just want to say, to stimulate your curiosity about the project. There are a lot of people that are working on that. They are students from bachelor, master, PhD as me, and they are male, female. We have a complete gender equality, a complete supporting environment for the students. And the things that I want to underline is that we are followed by ESA that permits these dreams come true, of course, because they can suggest us things and help us during the project. But we want to to make another step, and we want to reach the TRL6 by the end of February, by a test campaign in ESA. And that's all. I just want to conclude saying, okay, we are just students. We are very young. We are now facing the environment of space, but we can do something similar. And I want just to leave you with this message. Thank you very much.
Thank you. Thank you. Thank you, Federico, for this interesting presentation and also the stress that you put on disposal. Because I think, yes, I was reading, I'm not an expert, that now satellites are becoming cheap. And so from 100 million, they go down to 1 million. But then this means that more and more people will be able to launch satellites, and this also problem of the disposal will have to be addressed. So it's good that in a project is part of the project. Yeah. So thank you. Thank you, Federico.
Thank you very much. Thank you.
And now the last presentation always on CubeSat by Dr. Fabrizio Maccari of Politecnico di Milano. And the title is, I hope I'm not making mistakes, 6X CubeSat Politecnico di Milano student-made IOD mission.
Good evening, everybody. My name is Fabrizio Maccari, and I'm one of the systems engineers of the 6S CubeSat project. I'm here on behalf of Polyspace, which is the first space association entirely made by students of Politecnico di Milano. And I will introduce you our project, first talking a bit about our mission, about our payloads, about our orbit and our mission design. Then I'll talk a bit about testing, and in the end, I'll draw some conclusive remarks. So let's start from the basics. So what is 6S? 6S is again a CubeSat. As you can see there on the table, it is a 1-unit CubeSat, as my colleague before perfectly explained. It is a standardized size for a satellite mission, and in our case, it is the minimum size allowed. Our mission has two types of objectives: educational, as we are students. So our main goal is to provide hands-on experience to Politecnico di Milano students by working on an actual space mission while they're still studying. Then our second goal is more technological. Basically, we want to be an in-orbit demonstration mission in the field of solar power harvesting and also storage, as I will also explain later. Before diving into the technical stuff, I want also to highlight some recent achievements of our team. As our colleagues from Padova, actually together with them, we were selected for the ESA Fly Your Satellite Design Booster Program. So also us are currently working with the guidance of ESA experts, and this is really helping us a lot to grow and to progress with the project. And we also completed the phase B of our mission development, for those of you who are familiar with the concept of mission development, and we completed that in June 2023. Now, moving on, just what is an IOD mission? It is an in-orbit demonstration mission. Basically, it is a mission that is focused on the scientific or technological validation of an innovative solution that can be either an innovative instrument for science or an innovative piece of hardware or software that aims to be launched as a new product into the space industry market. IODs are crucial for this new technology, for the progress. Indeed, the in space conditions cannot be replicated for long periods of time on Earth. And therefore, to actually be sure that that technology is ready to be launched on the market and be ready to be implemented in actual space missions, it has to be demonstrated on orbit. And this is what we aim to do. Indeed, the CubeSats are also often used for IODs as they are relatively cheap, as they are pretty small, as you can see. And also, yeah, the process to build them is pretty fast. Speaking of our process, here just an overview of our team. We are all students of Politecnico di Milano. We are currently more than 100. Sorry, I got back. Yeah, we are currently more than 100, and we range from bachelor students to some PhD students. We have the most diverse engineering backgrounds in our team, with a predominance, of course, of aerospace engineering. In addition, we are also a very multicultural team with people from all over the world that luckily come to study to our university and also like to contribute to the project. For what concerns our partners, we have, of course, Politecnico di Milano, which is our university. Then we have 2 other universities helping us with one of our payloads, and they are University of Cambridge and Universität Potsdam. Then we have a startup that is Volta, which is providing the second payload, and it is a young Italian startup based in Piemonte. Then we are also relying on bigger external entities, such as The Orbit, which is an Italian company based in Fino Mornasco, near Como, and then ESA, of course, thanks to the Fly Your Satellite Design Booster program. In addition, we also partnered with LiveSpace for our ground station services. Basically, they will allow us to communicate with our CubeSat thanks to their antennas on ground. Now, to the fun stuff, let's start with our payloads, just quickly. I won't get too technical, luckily. So the first payload is PESCA, so it is a perovskite solar cells analyzer. Basically, we are developing in-house this PCB, so this printed circuit, to characterize in the long term the performance and in-space degradation of a new type of solar cells, basically of components of solar panels. These solar cells are made of perovskites, that is this new material that should grant an higher efficiency with lower production costs, a higher radiation resistance, which is key for space missions, and also they should have some potential self-healing effects. Our goal is to actually demonstrate in orbit these characteristics, and therefore we developed the circuit that you can see on the top of the slide to characterize all the relevant data for solar panels and see if in the long term there is the expected degradation. Then, for what concerns the power storage part, we are also testing the Volta structural battery. So Volta is a startup that aims to be the first one to build a structural battery. Basically, they want to build a battery that can serve both to store power and also to act as a structural component of the satellite, therefore sustaining its structure. This would be a real game changer in the industry because it would allow future space missions to be lighter and therefore far less expensive. As the technology is, of course, not ready yet, we are provided with this empty mock-up of the battery, and we will characterize on orbit its mechanical, thermal, and structural behavior in the long term to see if it actually is ready to withstand the structure of a satellite and all the loads that come with it. So, of course, by the simulation of the space environment. Then, we are going to achieve these goals in the low Earth orbit, so in orbits that are close to the Earth, with the orbital parameters, for those of you that are technical, that are listed here. So we didn't select a precise orbit, but we rather selected a families of orbit that should grant us enough mission lifetime to download all the interesting data that we need from our payloads, and also the telemetry of the CubeSat. Our expected operational mission lifetime is between 1 and 2 years, depending on the initial altitude we will be left in. And we have also selected a higher inclination range, so you can see high between 75 and 88 degrees. This means that the plane of our orbits is very inclined. This will allow us to have shorter eclipses, so for only short periods of time we will be behind the shadow of the Earth without seeing the sun to charge our batteries. We've also checked that with these orbits we have enough visibility windows to make contact with our ground stations to download all the data that we need. During the on-orbit phase, we'll have 3 main phases of our on-orbit demonstration mission. So first, right after launch, we have LEOP, which stands for Launch and Early Operations Phase. Basically, in this part of the mission, which happens right after launch in the first days of the lifetime of the satellite in space, we will commission our CubeSat after the first contact with our ground stations with the antennas of LiveSpace. Then we will move to the nominal mode, during which we will acquire all the data from the payloads and we'll download them on ground. And finally, we will have the disposal. So during this phase, we will basically passivate the satellite, and thanks to the natural decay of the orbit, will re-enter in the atmosphere, completely burning the CubeSats without leaving any debris in space. So also, as my colleague explained before, this way we are compliant with ESA regulations for space debris mitigation, as in less than 5 years, we need to leave no traces of our CubeSats in space. And this is what will happen with our mission. Now, I will show you quickly how we will govern our mission in space. Basically, our onboard computer will have implemented the state machine that we see here. Basically, we have 6 modes of use of our CubeSat. The main one, which is the green one in the slide, that basically is the mode during which we will do the payload testing and acquire the data. Then we have the 4 modes that you can see here in yellow that are standby modes, so modes that grant basic functionalities of the CubeSat. And then we have a safe mode, which is basically a survival mode that the CubeSat enters in when it recognizes that there is a failure on board, so it needs to save energy and to understand what happened, basically, and it can do that autonomously, but also with the support from on-ground command. Now I will take you a step back to the current state, so we'll put our feedback on ground, and I'll talk you about how we are testing currently our hardware. So, as for now, we have started testing on component level. So we are testing single parts of our satellite to see if they function as we designed them to do, and also if they grant the required performance. We have started doing that on the EPS-1 Plus module, which is a single module that acts both as a battery and as a power distribution unit. And as you can see also in the slide, we also tested our solar cells, in particular doing an electroluminescence test, as you can see here with the lighted up solar panel. Then we have also started testing on our onboard computer, so on the computer that will fly to space on our CubeSat. We are also cooperating a lot with Politecnico Milano and external entities to gain access to facilities that will allow us to progress with the testing and to the integration of our mission. In particular, November 10th was kind of an historic date for us, for Polyspace, as for the first time, thanks to the orbit, we entered in a clean room, and therefore we actually put our hands on components that will fly to space on a satellite that is designed by us, Politecnico Milano students, so it was a really important milestone for us. Then we are also developing currently a structural thermal model, so a model that will basically represent the structure and the thermal behavior of the CubeSat to be tested then at ESA facilities in Belgium, thanks to the Fly Your Satellite program. Now we'll just wrap up. So yeah, this has been a really enriching opportunity for us students of Politecnico Milano, because we are really complementing our preparation, pairing up the theoretical knowledge we are gaining in class with the hands-on experience on an actual space mission while we are still studying, and this is really huge for us. Then this experience is allowing us to build a solid network, and this can help the birth of possible startups, as it has happened in Polyspace sometimes, or also future job offers for some members of the team, so it is really important. And we're also getting used to work under ESA regulations following the ECSS standards, which are the go-to standards for space missions in Europe these days. Then, yeah, we have 2 future big challenges that are launch date definition, as we have to find a launcher, and we plan to do that by applying and winning potential student competitions that these days are really growing. And we'll also finish our Fly Your Satellite Design Booster program with ESA in March 2024, submitting our final design review to be reviewed by ESA experts. With this, I really want to thank first, the full Polyspace team who's making this possible, and also thank you for having me. It is, an honor for us. Thank you for the attention.
Thank you, Fabrizio, for your presentation. I would underline the passage when you said that there were participants in this project from all over the world, and this global spirit and global nature that space could have, it would be important to keep it. I spoke with a scientist who told me it's so important that more than one state gets together. Maybe one nation is good in landing, one nation is good in robotics, one nation is better. And so you could have a real global international space industry. But in our panel, we will also talk about security, and defense. So thank you again, Fabrizio, for your presentation. And now I invite the panelists here to join me. General Cipelletti, and as you like here, and Colonel Oberst Fraas. And General Vittori, Roberto Vittori. So we have to kick off this discussion. As I'm a journalist from Sole 24 Ore, I write about finance and economics. I wanted to throw in a big number. And this big number, I've seen it by the BDI here in Germany, and it's the growth of space-enabled solutions projected to grow from about 300 billion euro now to 1.2, 1.3 billion. So it's going to become the space industry a trillion industry. And so there is also a lot of interest on space by companies, and not only big companies, but also medium-sized companies. And this was also the driver of this action plan that was signed recently between Italy and Germany. And there is a part that mentions space, as it says that this action plan aims to strengthen our coordination of space, space defense activities, space economy, research, and also space legislation and regulation. So I asked to General Cipelletti, which are the latest developments in our bilateral defense relationship between Italy and Germany?
Okay. Well, thank you very much. First of all, good evening, everybody. Let me take the chance to say thank you to His Excellency the Ambassador for the much appreciated invitation to be part of this event this evening. Thank you so much. Just as you said, of course, there are a lot of there's a lot of interest in the space. There's a lot of money involved in the space business, of course, and there are a lot of activities that tighten the link between Italy and Germany, also in the space environment. Talking about the defense, we know that Italy and Germany have a long-lasting tradition in relationship for the production of capabilities in the, I would say, standard normal domains, the land, the sea, the air, and nowadays we are seeing seeking the opportunity to even strengthen our cooperation in the space domain. Let me mention, for example, the cooperation that has been going on between Italy and Germany since 2015 for the European Space Surveillance and Tracking Initiative, that basically sees nations such as Italy and Germany put together their capabilities, their sensor, in order to be able to track the objects in the space. So we can even strengthen this capability by achieving even more sensor both in the ground and on the in space, in order to increase again even more the capabilities to track the objects in the space, which is also part of what has been called by the European Space Security and Defense Strategy, calling for an increase in the capabilities to reach the space domain awareness, to the complete awareness of what's going on in the space, and that's very important for the space defense, and is very important also to protect all the assets built also for economical purposes in space. Something else that has been mentioned before by the ambassador is also the agreement between Italy, France, and Germany to boost and renovate the capabilities for the European access to space, which is something we are really lacking in this time. So has been renovated the agreement between these three nations to develop even more capabilities. And the Italian defense, for example, is looking very closely in what we call the responsive space capability, the capability to reach space with systems that are very flexible, very timely to be deployed, and the capability to deploy satellites that will be very small, a little bit bigger than the satellites we've been very interesting in the presentation we had just a few minutes ago. And I think that with the tactical capabilities that we are facing both in Italy and in Germany, this might be a very interesting discussion going on in order to be able to fix the problem and find a common solution to that capability as well.
our two countries are already very close on space, so we have to find ways to strengthen, but the work has been done together, I believe, by Italy and Germany already on space.
Absolutely. I think that every nation that is a spacefaring nation mentions the fact that space is a collective endeavor. No nation can do and manage the space, especially with the defense perspective, by itself. So collaboration is very important. As I mentioned before, there's a long-lasting tradition. And I think that I can mention as well, Italy has been invited, and I will be back in Berlin next week to sign the joining of Italy to the Combined Space Operational Initiative, which is a very important initiative, and Germany has been part of this initiative together with France, the United States, the United Kingdom since a few years ago. We are very proud that Italy has been invited to join this initiative as well, and I'm sure that this initiative will be another place where we could share our needs, common requirements, and develop new programs together, fulfilling the requirements of this initiative for the whole Western countries, I would say.
Thank you. My question to Oberst Fraas, as I've been writing about this, and so I take the opportunity also to ask you, my question starts from the Zeitenwende. I mean, this was really the turning of a new era for your Bundeswehr, and it's not only, I think, a matter of spending. Of course, we all wrote or talked about this special defense fund by 100 billion to be spent in many years, but still. But apart from the money, I think it's, can you tell us a little bit more of this, what we see, a revolution that is taking place in Germany, and how this can affect our relationship between Italy and Germany?
Thank you very much. I'm of course delighted to do so. Excellency, generals, ladies and gentlemen, of course I would like to take the opportunity to express my greatest respect and admiration for Italy as a country, your culture and your customs. I love your country very much. It is of course also a great honor for the Cyber and Information Domain Service Headquarters to be invited to this event, and I would like to offer a few aspects on our space-related business. Zeitenwende. I think most often when you talk about Zeitenwende, people talk about those 100 billion euros that the Chancellor has dedicated to the armed forces. I do not think that that is the most important aspect. That is just money, and it will be spent on materiel. 20% will be spent on cyber and information service issues. But I think the greater issue is the change in mindset to refocus on defending our countries, on defending our like-minded countries, our alliance, mostly countries in Central Europe and North America. We will need to refocus on being able to fight major joint combat operation in the framework of the alliance or the European Union. Your question was also asking how does that affect the German-Italian or the Italian-German relationship. I don't think it affects it very much because the relationship is very stable, very robust. I have fought myself alongside the Italian 28th PSYOP Regiment from Pesaro in Afghanistan, so I am fully convinced of the Italian army and the Italian armed forces. They are extremely professional, and I don't think that it affects that very much, but we will together need to refocus on defending our home countries. My last point is, we'll need to see what will happen in the United States next year, and that may be a hint to strengthen our European pillar of, defending our countries.
Thank you. Yes, I think it's been the stress is on security and defense after Europe discovered that our peace after the Second World War was broken suddenly and maybe unexpectedly. So now we have a war in Europe, and so this is why in Germany there is also this new mindset, but I think also in Europe we are going through a Zeitenwende, I think. So my question to General Vittori, just because we also heard these presentations, and one was from a high school, so there is this interest is expanding on space and going maybe beyond the defense or beyond some big companies. I mean, it looks like the space can be closer to more people, more companies. But from your point of view, is this true? I mean, how can we approach space?
Thank you for the question. Before I get into it, I would like to give some context to my presence here. I'm very happy to be with you for multiple reasons. First of all, in Germany, there is the European Astronaut Corps in Cologne. Then with Ambassador Barricchio, I spent an important part of my career being the first space attaché and space diplomacy. We talk about space. Space is now a lot more than was before. One key element is space diplomacy, and I need to thank you, Ambassador Barricchio, for guiding me through an important step. And something else that I'd like to remind everybody is that space diplomacy started with Italy in September 1962, when the Vice US President Johnson flew to Rome to sign the first space agreement for San Marco with the Italian government. The other reason is Italian Air Force. In Italy, space started with the Italian Air Force. This year is 100 years of the Italian Air Force. Paolo Tarantino here is one of the future leaders of the Italian Air Force, and I thank you for having me here today. Now, space. Initially, 1957 was a single satellite. Then we start to do a lot more, and now space has three main identities: civilian space, military space, and commercial space. Those are very different from each other, and it's sometimes difficult to understand how they interact one to the other. The most difficult to understand is the civilian, the so-called commercial space, because it's a bit civilian, a bit military, but sometimes we see tourism. What is tourism? Tourism is like a curiosity. What is a suborbital roller coaster? Tourism is the wrong interpretation of space. The real interpretation is what we have seen today with these new ideas coming from students, university, researchers. This is especially if we look at the next 20 years, that will be the surface of the moon. Sometimes, something else that we confuse is we talk about space indicating anything that is outside the atmosphere. But in reality, we need to be more precise. Are we talking about satellites? Are we talking about the surface of the moon, the partial gravity? Are we talking about Mars? They are very different from each other. They require different technologies. They offer different opportunities. So yes, seeing from an economic standpoint, we know that space, the value is about $500 billion. And eventually, we will quickly double up. But that is primarily services from satellites. So if we talk about usage of extra atmospheric resources, for example, we go to a gas station, we refuel the car, but what we use to refuel the car is hydrogen, with the hydrogen that is coming from the surface of the moon. Is that fantasy? No, it is something that it can be a reality. There are a number of technical questions that we have to answer. So I invite those beautiful initiatives with CubeSat to also look beyond Earth orbits, low Earth orbits, think about mobility on the surface of the moon. CubeSats, in the future version, there will be drones. Drones on the surface of the moon will be derivative from the concept of CubeSat. So I invite you to think beyond the 200, 400, 800 kilometers horizon of the CubeSats today, and think about to our next challenge, next opportunity, the extra atmospheric resources starting from the surface of the moon.
Thank you for reminding us or telling us or teaching us the complexity of space and how we can approach it. As I was making some research for this panel, I read that from space, for example, we could have our solar panels in space. But I think it is, yes, as you say, you have to define what kind of space you want to address, and space is not, I mean, Mars and Moon already are two totally different ways to approach space. So we have a lot, I think, of ground more to cover. But taking also from what General Vittori was saying about civilian, commercial, and military or defense, what we are told is that the drive for innovation and what is discovered for purposes of defense is the avant-garde, is the big innovation. And then from defense, it goes and spreads to the commercial or to the industry. Would you say, first of all, if this perception is true, and if it will continue in this way, do you think?
Okay, thank you for the very good question. Kind of complex to answer. I think that it used to be like that. It used to be that the defense, or at least the governmental programs, used to lead the technology and the innovation. Let's think about the Race for Space at the very beginning, all governative initiatives, scientific endeavors. And then we got to the commercial phase where the technology was driven by commercial interests. And to my point of view, we kind of missed the opportunity to lead the innovation, the technology innovation for space for the defense point of view in the last couple of decades. Nowadays, as General Vittori mentioned before, there are a lot of initiatives, civilian, private, commercial, that are actually driving the innovation, and that are giving us, also the defenses, new problems to solve and new capabilities to manage. The access to space is becoming more and more easy for everybody. More nations are accessing to space. Space is less expensive, so more nations are actually capable to cope with the goal of achieving capabilities in space. We are seeing commercial endeavors in low orbits. Let's think about Starlink, for example, but that's not the only example I can think of. Let's think about suborbital flights, the capability to reach space from the ground and land back again and again on the land, reusability for launchers to access the space and stuff like that. And the defense has been observing these changes and not leading the change. So nowadays we have to, first of all, understand all the capabilities that have been put in place by commercial, private endeavors, because these capabilities can be used as military assets for us or against us. So first of all, we have to understand thoroughly what we can achieve and what our opponents can achieve in space thanks to the new technologies. And then we have to drive back the lead, we have to take back the lead as defenses to understand exactly what capabilities we need to put in place in order to drive the change and give us and our nations the capabilities to defend us in space from the new capabilities that are available to not necessarily our colleagues and partners.
Out of this innovation that is speeding some not in the defense sector, would you think that there is also artificial intelligence? I don't want to open here this, it is the biggest debate at the moment, but I'm just wondering whether this could be one of these developments that you have to be careful about.
First of all, I have to say I'm not an expert in artificial intelligence, so I don't want to say things that I'm not expert on. What the Italian defense is looking into, definitely the application for artificial intelligence to manage the complexity of definitely several activities that we carry on space. So the answer is yes. I won't be able to explain to which extent.
I don't think many people are experts of artificial intelligence yet. I mean, we are really, really at the beginning of this new revolution. But to Oberst Fraß, I like, because you mentioned we'll have to see what happens to the elections in the United States next year. So my question would be, how can we coordinate, let's say, also this relationship on defense and space? We talk about the bilateral agreement with Italy and Germany, then we mentioned the trilateral agreement, then there is also a European contest that is it is dominating, I would say, in our agreements between states, and then there is NATO and the United States. So how can we all coordinate all this to make it better?
Ma'am, I think your question is guiding at the bilateral opportunities that are offered between Italy and Germany, and I see two aspects in the field of the military use of space. The first aspect is joining ideas within the Combined Space Operations Initiative and Operation, I don't know whether it's okay to name the operation, but you know what I mean, sir. And I see four aspects in this, and that is space situational awareness, space operations, space support to operations, and operating space systems. And I think if we can influence CISPO in a way that it does accommodate the European ideas best and the bilateral ideas best, I think that is a great field where we can cooperate. And the second field is IRIS², which is going to be the largest European satellite communications network, which is going to be tri-orbital, currently under development in the European Space Program Agency. And I would like to see what the Italian ideas are on, for example, hosted payloads. I think there's ideas being shaped on the ground segments in Italy and Germany. So to sum up, two fields, Combined Space Operations Initiative and the subsequent operation, which you are acquainted with, and cooperating in the field of IRIS².
Thank you. Oh, by the way, you see all these pieces of paper and you think they're filled of questions. Because I'm a journalist, of course, I have many questions, but we are also expecting to have questions from the audience. So we will have some time for that, and as I finish the round of my questions, please think about your questions to this very special panel. So, General Vittori, we have the International Space Station, ISS. It is a joint venture with the European ESA, if I'm not mistaken, US NASA, and then the Russian RKA, Japanese JAXA, and a Canadian. But I mean, what is the future of this, of ISS? And also, do you think that this station could be run in the future by private individuals, if only for research?
So the International Space Station is, has been identified as the most evident success of human engineering, an incredible success also seen from the point of international cooperation. NASA, Russia, Europe, Japan, and Canada. It is so incredible that even today, on board of the International Space Station, we work all together. So that's an unbelievable success. And we're talking about human space flight, obviously. The International Space Station is 400 kilometers from the surface of the planet. Having said so, there is also the other side of the coin. we were saying before, civilian space, military space, and commercial space. What is the meaning of the word commercial? That is the most confusing. Some key words is efficiency, low cost. The International Space Station is a huge cost, incredible. So there are the two sides of the same coin, the success and the cost of the operations. For the future, what we need to do is we have to find a way, if we really want to use the potential of space, we need to work and make, first of all, access to space easier, more economic. So for many, many, many years, it's like a given. Rockets are one-way ticket. Rockets is like the Flintstone, okay? Trying to move a car that the wheels are squared. We need to find a solution. Elon Musk is trying to land the rockets. It will not work. Eventually, yeah, he has done a lot already, but for the future, what we have to do is to take aircraft and make them to evolve into spacecraft. So you take off from a runway, you go to space, you launch your satellites, you bring your astronauts, you do whatever you want, come back, land, refuel, and go again. Is that impossible? No, it is possible. Why we are not doing it? It is the way history went. It was 1957 when the Sputnik was launched. That pushed the technology toward the rockets, and the US made a huge mistake. They had an agency called NACA. NACA was an agency that was evolving the aeronautics technology, aircraft that were becoming spacecraft. The X-15, you can look it up on the web, was an incredible spacecraft. We all know that the first astronaut was Yuri Gagarin. We do not know that the first astronaut that flew twice, was John Walker, that was flying on the X-15. So that is to say that, yes, it is important to talk about space, but it's also important to understand that there are different domains. If we talk about satellites, that is the Earth domains. Satellites are a little bit like antennas on a mountain. They provide very important services, but those are only services. It is, if we talk about aerospace, that is access to space. And it is key if we want to give a real meaning to the word reusability. The next opportunity, as we were saying before, is the surface of the moon. That is 400,000 kilometers. The International Space Station is 400 kilometers. So there is a factor of 1,000. 400 kilometers is the International Space Station. 400,000 kilometers is the surface of the moon. 400 million kilometers is Mars.
Very, very interesting. And yet, unfortunately, by flying so high, I'm bound to ask a question to General Cipolletti on the Russian attack and the invasion of Ukraine, which we have been said started in space with an attack on a satellite. And so geopolitics now are taking over all aspects of our life, and maybe also can you tell us how this war has changed or is changing the defense and the space strategies, given that also we have another conflict and we have also tensions in Asia. So we live in unprecedented, dangerous times.
Definitely so. First of all, let me say that the war in Ukraine just basically confirmed the tendency we already observed as defenses, and that NATO stated the space as an operational domain before the start of the war. So I think that we were all agree that space would have been, and is demonstrating to be nowadays, a new arena for combat, even if not in a standard way of combat as you can understand. We observed several lessons learned from Ukraine that, of course, we are taking into consideration. And mainly, we observe, first of all, the importance of space to have an effect on the war. Russia, of course, has been able to negate the capabilities of space for the Ukrainian communication system. But then, of course, the Ukrainian, together with some help from other countries, have been able to counteract these capabilities. And without the perfect control of space, no Russia or Ukraine are able to actually have an overcome in the war. So that's the first lesson I identified. The second one is, of course, the importance of communication from satellites, and of course the importance of being resilient. Now, the Russians have been able to jam and overcome the capabilities of the Ukrainian, but then again, you may find some other ways to have different capabilities, let's think, for example, Starlink and commercial capabilities. So the resiliency of your capabilities for SATCOM communication is very important. Earth observation. We have very strong capabilities in Earth observation. The capability to observe what the adversary is doing is crucial to any kind of war, and Ukraine is proving this kind of effect. And of course, you have to have different sensors in order to be able to observe your adversary also in adverse weather conditions. So you want to have sensors that are working in different spectrum just to be able to overcome maybe weather problems or anything like that. What we are observing also is the importance of electronic warfare in the Ukrainian conflict, so the capability to fix the problems caused by jamming, for example, for our SATCOM capabilities, and also to be able to counteract cyber attacks. That's another issue we are facing. Going back to the question about how this is affecting our strategies, I would say that the strategy we already had in place were looking to fix this kind of problems. We were anticipating this kind of problems. What the war is actually leading is an acceleration in the need to fix the problems in advance, because we thought probably we had more time in order to be able to fix these kind of problems and be able to respond to these kind of problems. The war is actually proving that we have less time in order to be able to reach these capabilities in a short amount of time.
Thank you. Thank you for this reply that leads me to the next question to Oberst Fraß, in the sense that just about what General Civelletti said, what do you see are the future challenges for space and defense?
I believe the future of military warfare will be multi-domain operations or joint all-domain operations. What is this? It is fully or thoroughly digitalized and fully automated, or maybe even autonomous military operations where the kill chain between sensor and shooter will be extremely much faster, and sensors and effectors can be used across a range of domains. The most important prerequisite for multi-domain operations is access and a free use of space and cyberspace. So our enemies have a great incentive to exploit our vulnerabilities in space. I would assert that if you are able to hamper your opponent's space or cyberspace, you have gigantic advantages in military warfare. This also means that we will need to mitigate our own vulnerabilities that we have in space, and I think that is the greatest challenge. How can we hamper our enemies' use of space, and how can we protect our own use of space? The German answer is that we will need a comprehensive space architecture to dramatically increase the resilience of our space systems and to increase their performance. There will be a mixture of satellites operating for the German armed forces. It'll be own military satellites, it will be satellites of partners, and it will be satellites of commercial companies. Once we set up this comprehensive space architecture, we will dramatically increase our own resilience and performance. This does, for example, include laser communication in between the satellites to make up for losses that are created by our opponents, and to equip our satellites with, for example, surveillance of their surroundings and so forth. So, what is the most important challenge? It is to cope with the enemies that are most likely, and they have a great incentive to hamper our use of space, and we need to mitigate that.
And by what you said, more and more I'm convinced that a European single defense would make us stronger, no? Because there is also this idea that, yes, we are together, we have bilateral agreements and we want to work together, but also sometimes we are in competition amongst ourselves in Europe. I mean, wouldn't a European defense ministry or a European, I mean, why are we at least moving towards that? To make all this to-do list, I mean, one country alone cannot do it.
I would say that IRIS² is a very important step towards European collaboration in the use of space, but I would also say that the satellites that the militaries really own, which is intelligence satellites and C4ISR satellites, they are extremely sensitive. But I do think that in the European Union, it is a good idea to collaborate a little bit more, for example, to share data relay stations in geostationary orbits for laser communication and so forth. But IRIS², we should take that as a very as a very big step.
Yes, yes. Yes, I do pose questions like a journalist, so I'm not a specialist. But my last question is the question that we all like to ask to General Vittori, is as there are many young participants in this event, and so what is your advice if one person would like to become an astronaut or would like to work in space? What is a piece of advice?
I was expecting the question, how is flying space? But yeah, what's the advice for, I guess that's the wing of the future astronauts. My selection was in '98, before that was the Italian Space Agency, the ESA. The first ESA selection was in 1992, then the second in 2009, and the third in 2021. So it's each time 4 or 5 astronauts. Those numbers are not huge. But if you put ourselves into the future, depending on the success of something that is going on right now, down in Texas, Boca Chica, have you heard of Boca Chica before? This little town, no one knew about it until Elon Musk decided to build, I forgot if you call it a space city or whatever. They are building this giant rocket called Starship. That is the one single element can make the difference between the way we do operation now, that again, each year only a few can fly to space, to the moment when space could be accessible to hundreds at a time. What are the chances? I don't know for sure, but the only real problem that I see with the Starship is the way he's trying to land. So you take a 55 meters tall building and just let it fall down. Like you take a bottle, leave the bottle will fall down. So that's not a bottle, it's a 55 meters tall building, simply free falling. At the very last moment, you control with the engines, put yourself straight up, you turn the engines on, and you land softly. Would you be willing to be on board? I would.
If you drive, yes.
If I try first, then you will come next. So before you were mentioning artificial intelligence. Yes, all this is possible because of the artificial intelligence. The human brain could never fly the way they should be flying. I don't see this as the real future. You can use it for cargo, not for humans. So for the humans, we need to wait for the Elon Musk version of the individual that will follow my advice, horizontal takeoff and horizontal landing. And in the 100 years of the Italian Air Force, that's the way we have been doing, that's the way to do it.
Thank you. Thank you for this very stimulating and interesting discussion. Now I want to see the organizers if I have time to take questions. Yes, because we are a little bit over, but I really would like to give a chance to the audience to ask questions. Because I do know that I asked so many questions that then not many people have more, but I wanted to give this chance. If there are no questions, yes, here, please. Please introduce yourself.
Thank you. Thanks to all the panelists for such an interesting evening. My name is Esther Sabatino. I'm a research associate at the International Institute for Strategic Studies here in Berlin. And so the topic of private actors was quite a recurrent one. And we know that the US also rely on private services. The DoD relies on that quite substantially for redundant data, and the US is also the country that provides the most data inside NATO for satellite, satellite data. And so I wondered if you could tell us a little bit more how much Italy and Germany rely on private sector to have this second layer of data. And when it comes to NATO, we know that the NATO space strategy does not foresee NATO to own space capabilities. And I wonder if instead it would be wiser to go for another type of capabilities like AWACS and AGS, so to have NATO-owned space capabilities. Thank you.
Thank you. I don't know who would like to answer even part of this question.
I can try to take a bit of the answer. Well, talking about Italy, of course. Nowadays, we rely only on military capabilities for our defense purposes. What we're looking for is actually try to integrate our military capability with a little bit of commercial capabilities. Just because we need, as I said before, to fill in the gap quickly. And of course, there are commercial capabilities that are already in place in specific environments, so then we can actually use this kind of capabilities to integrate our capabilities while we are growing new by capabilities owned by the defense. It's very important to us not to rely only on commercial capabilities, because just as we said before, as we've seen in Ukraine, for example, if I rely one capability to a commercial provider and then he decides that he doesn't want me to have this kind of capability anymore, then I'm prevented from the use of this capability, and that is not acceptable to us. So yes, we are looking to integrate some commercial capabilities in our capabilities, but not to replace commercial or military use capabilities with commercial ones. Going back to the NATO question, that's a very interesting point, I think. Nowadays, again, going back to the need to expedite the process of having in place different capabilities, as you mentioned, NATO does not own any space capability, and I think that it would be much more interesting, and I agree with what my colleague said before, for single nations to either develop by themselves a few capabilities that they could pool to or put together available for other nations or for NATO. Let's say, for example, SATCOM. You probably know that there is a SATCOM new generation team made up by 4 nations that are providing SATCOM capabilities to NATO. That's what I'm referring to. What I would like to have from NATO would be funding from the nation that would be able to develop new capabilities by themselves or in team, in partnership, so that I have the funding to build a capability that then I can provide NATO with. So I can be faster than working with maybe the European Commission or community, with NATO, with just a few nations, then we can be faster, but of course we also need the funding, and NATO could provide us with that.
Thank you. Do you want to add something, or?
The first question is a very great concern of ours. Why is that? We are refocusing to fight major joint combat operations against opponents that are able to fight big style, right? So we go from international crisis management to those big combat operations. I think we have a problem using commercial assets when you look at international law. A lot of those functions are combatant functions. So it is not legal for a civilian to perform combatant functions. It seems very attractive to, for example, use Starlink for satellite communication and military operations. I'm not judging, but I'm just raising the question, is it legal for a civilian person to do, you know, very central ISR or communication services? I doubt it. And why would a third nation, for example, create a legitimate target in their own country? But I do have to say that we have, as I said, a certain mixture of own satellites, interagency satellites. For example, our weather satellites are not owned by the military, but owned by the Department of Commerce. Or extremely important in modern style warfare are our PNT satellites, our GNSS satellites, to provide the PNT signal. Extremely crucial. How can that be operated in times of war? A very, very big question. NATO, I don't know. It does sound attractive, but we have many capabilities that are owned by the nations, and I know for Germany that until, I would say about 2045, we have ideas shaped on how to use space, and there's just, you know, so much resources, and they are dedicated towards certain projects. That's my answer to that.
Okay, well, I would think I would close the discussion here. I was told also that there could have been the pills that the astronauts eat are being prepared. No, I got it wrong. There won't be pills or special astronaut food, I think, but there will be a reception organized by the embassy and also by SIGN, which is a network of scientists in Germany. So thank you so much to our panelists. It was a real pleasure to be moderator tonight. I learned a lot. Thank you for the audience and for the presentation of the students, and if you like to ask questions, you can ask them later on. So enjoy the rest of the evening and fly high.